All right, y'all, today we're going to review some algebra. So the first problem we're going to take a look at is f of x equals negative x squared minus 9x plus 3. And we're going to solve for f of negative 3. So all you need to do here, my advice, is line up the f of x with the f of negative 3. And then what we want to see is that everywhere that I see that I have an x, I'm going to replace that x with negative 3. So this is going to be negative 3 and negative 3. So what this is saying is the function is given as such. Basically whatever I'm putting in parentheses, I'm going to square it, multiply by negative 1, then I'm going to subtract 9 times whatever's in the parentheses, and then add 3 to it. So once you see that and once you line it up, then it's about solving. Now, one careful thing about solving this is you do have to follow PEMDAS. So I have to do parentheses first, negative 3 squared being 9. Then technically, you are going to next multiply. So I already did that here when I did the negative times the 9. Note this is 9, but we'll write it as negative 9. Over here, we're going to do negative 9 times negative 3, which is positive 27 plus 3. And then we'll just add these up. So 27 minus 9 is 18 plus 3, which is 21. Okay. One little trick here in regards to how to think about putting these together. This is extra, you don't need to know this, but I always like to show students this. If I clean this up, I have one negative 9, and then negative times a negative is a positive, so I have 9 times 3, right? So if I lose one 9 and I gain 3 9s, that means I have 2 9s, which is 18. It's just a different way of thinking about how to add and subtract, but it's a pretty useful method as numbers get bigger. So I always like to show students that. But again, all we're really doing is we're replacing x with negative 3. Solve the equation. If you were given a calculator, you could type it in all at once, and it would give you 21. Okay, let's take a look at another problem. So the next question is asking, what does a do? And I should have written to y equals ax squared. And anytime that you have a graphical question, my advice is to use a graphing utility like Desmos to kind of play with it. So that's what I'm going to do here. Give me 1 second. All right, so I'm going to go to Desmos, and we're going to go to the graphing calculator. And the cool thing that I like about Desmos is I can write y equals ax squared. I can get an a, and I can visualize what a does. So as a gets bigger, note what's happening. The graph is getting thinner. And then as a gets smaller, the graph gets wider. If we think about this, that makes sense, because what we're doing is, if the parent function is y equals x squared, what we're doing to the parent function is we're multiplying it by a value in front, right? So as the value gets bigger, what's happening is whatever point you have is getting higher, right? So for example, if I leave this as y equals 2x squared, and we take the point 1, 1, which is, let's say this is just a random initial point. So here's 1, 1 as a random initial point. Well, in my new graph in red, y equals 2x squared, it's going to double the point. So if it's at 1, it's now at 2, because 1 times 2 is 2. So notice that it will be, in fact, at 2, 2. I'm sorry, 1, 2. All right, I'll call that new point. Okay, so we can see here that this 1 gets doubled, so now it's at 2. you can see that if I gave you another point, 2, 4, now I have to pick values on the parabola, right? So what I'm doing is I'm basically plugging in 2 here and squaring it to get the 4, right? You can see you have a point here. Well, what do you think is going to happen? Well, if a is 2, then I'm doubling that. So 4 doubles to 8. So if I look at 2, comma 8, right? Look, that's on the red graph. And that's what all that's going. So the effect of that is it's doubling the y value. And then clearly if a becomes a fraction, then it's becoming like half as much, a third as much, etc., etc. Now if you think about this, so as a gets bigger, it hugs the y-axis. As a gets smaller, it actually goes away from the y-axis and it starts to hug the x-axis. What happens at 0? It becomes a horizontal line. So note, the graph is slowly pulling away, going down. If you think about it, as it slowly pulls down, it doesn't just stop, it keeps going, right? So that's why when it's negative, we call that a reflection over the x-axis, and it has the same effect. So as it becomes bigger as a negative, it's starting to hug the y-axis more, okay? So that's sort of the effect you have. What you'll see a lot of teachers do is they'll refer to a in terms of the stretch and the shrink as the absolute value of a. And all the absolute value does is just say, hey, whether you're negative or positive, if the bigger the a value gets, the more it hugs the y-axis. The smaller it gets, the more it goes away from the y, or it starts to hug the x-axis. Okay, I hope that makes sense. Let's look at the next one. So our next question is, given y equals 2x squared plus 4, how do you find the vertex? And so to find the vertex, there's 2 ways. If you're ever asked this question, there are 2 ways to find the vertex. One way we use, and what I think if they're asking you directly, is just to use x equals negative b over 2a. So every quadratic function fits in the format of ax squared plus bx plus c. Sometimes you have to do some algebra to manipulate it to that, but you can rewrite it that way. And so ours is y equals 2x squared plus 0x plus 4. So note, there is no bx term here. There is no linear term. But we can always create it by putting in a 0x. And that is a very common procedure. And then all you have to do is plug in the values. So a is 2, b is 0, as we just finished discussing, and c is 4. So this is a, this is b, and this is c. Then all I have to do is just plug into this equation. So x equals negative b, b is 0 over 2 times 2. So x equals 0 over 4, which is 0. So my x value is 0. And then if I want to find my y value, all I need to do is take this x equals 0 and substitute it back into the original equation. And y will become 4. And the cool thing about this is you can always confirm, right? Because if I plug in, if I say y is 4, x is 0, so just to be clear, I'm substituting in x is 0 and y is 4 into the original equation, it has to give me something that's valid. And because it's valid, that means this point is correct. So my advice, if they are asking you to go directly, algebraically, to finding to find the vertex, negative b over 2a is a great tool to doing that. And then just take that x value and substitute it back into the original function and find your y value. Okay. All right, so let's look at this question here. So it's asking us to graph y equals negative x squared minus 10x minus 24. So there's a couple of things we can always do to start something like this off. One, from what we discussed earlier, because a is positive, right? I'm sorry, A is not positive, A is negative. Because A is negative, we know that the parabola is going to be going down. By the way, the math way of writing negative is to say A is less than 0. Okay, so we know that this figure is going to be going down. Also, to find the intercepts, this is an important idea. The x-intercept is when y is 0, and the y-intercept is when x is 0. So, in other words, what I would highly recommend anyone to do is just realize that anytime we talk about intercepts, the other letter is 0. So let's do some algebra here. We have negative x squared minus 10x minus 24. And let's use some algebra. Let me double check just to make sure we're right. Yeah. Let's use some algebra to find our x and y intercepts. So the x-intercept I said was when y is 0. So that's here. So we're going to make y 0. And we're going to solve this. And so to solve this, the big thing is, even if a is negative, you can always divide through by -1. And rewrite this as 0 equals x squared plus 10x plus 24. The reason why I want to do that is I'm going to factor this. And what I can do to factor this quite easily is it's a lot easier to do if the leading coefficient, if a is 1. So how do we factor this? Well, you're basically reverse foiling. So you're going to look at x squared. You're going to say, hey, what times what is x squared? That's just x and x. And then you're going to take 24 and you're going to ask yourself, what times what is 24? So we have a couple of these. We have obviously 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And what I like to do is tell students is just, I don't pay attention to the signs initially. I just say, hey, what can we add or subtract to get to 10? Well, clearly 4 plus 6 is 10. So we'll go plus 4 plus 6. And then via the zero factor property, which is just a fancy way of saying 0 times anything is 0, I can say x plus 4 is 0 and x plus 6 equals 0. So x is -4 and x is -6. So now I know I have zeros of -4 comma 0 and -6 comma 0. And what I can do now is find the y-intercept. Now the cool thing about the y-intercept is if you think about it, I said the y-intercept is when you substitute in x is 0, right? Well, when I do that, what's going to happen is anything that has x is just going to go away, and y is just going to equal to the constant or the number by itself. Okay, so now we have interesting points. We have 0, -24. We have the y-intercept, which is, I'm just going to arbitrarily put it here as -24, so 0, -24. And then my x points are going to be -4, 0, -6, 0. So -4 and then -6. Be careful, right, with labeling negative values. And we need another point. We need the vertex. So remember, we said, well, how do we do the vertex? That's just -b over 2a. So -10 over 2 times -1, which is 10 over -2, which gives me -5. And then if I want to know the y component, I just substitute it back in. And so this will be -5 squared, which is 25, so -25. Negative is a positive, so this is plus 50. Minus 24, this is 25. Minus 24, which is 1. So I know that my vertex is at -5, 1. Also, the vertex provides an axis of symmetry, so it should be dividing the parabola in half. And I know that -5 is between -4 and -6. So that's kind of like a good little tell of that that's gonna work. All right, so it said we needed 5 points. I have 1, 2, 3, 4. Now, two really cool things you can do to find your additional point. I just told you that the jump, if I jump from here to here, from the axis of symmetry, they should be the same jump. So notice, if I'm at -5, if I jump 1 to the right, I'm at -4, and if I jump 1 to the left, I'm at -6. So if I jump from -5 to get to -24, or rather to get to 0, that's obviously a jump of 5. So I can jump 5 this direction, which is -10, comma, -24. So every point in the parabola, as you jump left, you jump right the same amount, and should put you at the same place. So we got all our points. We've drawn the parabola. What we can always do, and what I would encourage you to do if you're practicing, is to confirm your answer. All we do again is you can always just jump back to Desmos, and we can just graph it just to confirm. And no matter how confident you are, it's always a nice thing to just confirm if you're doing something for the first time, because it is always easy when you're doing these problems to make a silly mistake. And let's see here. So if we look here, cool thing about Desmos, I can literally click on the points. We can see that those points match up. It knows to find the intercepts. Look at that. And then the only point I need to find is see if -10, -24 is valid. Two ways of doing that. I can obviously just type the point in. And we can see that it is on the graph. You can also hit this cogwheel, and what it does is it lists the points. So I can get all those wonderful values, but if I need -10, I can go -10, -24. So something that's useful to do in general is once you have your vertex, let's say I start with, let's say I'm starting with -10 here. And what you saw me do earlier is I just hit enter. So I could hit enter a bunch of times. Maybe I have to put in a couple values here. Hold on. Let me delete these. So because I think you need values. I think they have to have nothing there for you to do that. So now if I hit enter, guess not. Yeah, there it goes. I guess I have to do a couple values. But it'll list, and what I really want you to see in this is the symmetry here. So notice the y values, you go, this is 1, this is 0, this is 0. Then you have -3, -3, then -8, -8. This is a key feature of the parabola, and this has to do with the fact that if you jump 1 here, you jump 1 here, because these gaps are the same, right? 1 jump, 0, 1 jump, 0, 2 jumps, -3, 2 jumps, -3, etc., etc. So hopefully that makes sense. Let me know. Please feel free to post any concerns about this in the comment section, and I will address them. But there you have it. So hope this works for y'all, and I will catch you in the next math video.